Okay, good evening all of you. How are you all? Okay, so in the last class we were doing that trigonometry, and the last two topics we have done. First one was that trigonometric ratios of complementary angle and the trigonometric identities. And I have given you some questions. I hope you have done those questions. So let us discuss some questions based on that one. Then at our scheduled time, we will start the next part of the trigonometry, which is the applications of the trigonometry, or basically the height and distance part, right? So there were some questions. I am discussing those questions one by one, right? Like in the sheet which I have given to you, there was question number 7 of based on the trigonometric identities. It was sin theta minus 2 sin cube theta divided by 2 cos theta. It was 2 cos cube theta minus cos theta, and we have to equate it to tan theta. So now this time you can see the right hand side, it is already in the simplest form. Only the thing is that we have to focus on the left hand side, and we have to simplify that one so that it should be equal to the right hand side. So as you can see here, what we can do, from the numerator we can take something as common, and if you look properly we can take sin theta as common, and from the denominator we can take cos theta as common. So taking sin theta as common, it will make 1 minus 2 sin square theta in the numerator, and 2 cos cube theta minus cos theta, we can take cos theta as common. That will become 2 cos square theta minus 1. Now this sin theta and cos theta, that will become tan theta, sin theta upon cos theta. We have to focus on this part. We also know that sin square theta plus cos square theta is going to be 1. Using this identity, we can convert the thing in the parenthesis either in the numerator or in the denominator. Either we can make sin theta into cos theta or cos theta into sin theta. So this sin theta upon cos theta, I am writing this one as tan theta. Now let's say I am changing the numerator part. So 1 minus 2, in place of sin square theta I can write 1 minus cos square theta, and 2 cos square theta minus 1 in the denominator. Now this will lead to 1 minus 2 plus 2 cos square theta over 2 cos square theta minus 1. Now this is 2 cos square theta, 1 minus 2 is nothing but minus 1. So basically this numerator part and denominator part both are same, so they can get cancelled out. So we will be left only with tan theta. So we can say LHS is equal to RHS, hence proved. So here in this question, what we have done, just taking sin theta as common and cos theta as common, and using the first identity, which was sin square theta plus cos square theta equal to 1, we can convert the sin square theta in terms of cos square theta, and the things get cancelled out. So this was the question number 7 part. Next question, there was question number 8. It was sin A plus cosec A whole square plus cos A plus sec A whole square this was the part. So now we have to solve that, show that left hand side is equal to the right hand side. So what we can do, we can see the left hand side, it is in the form of a plus b whole square, or two things are there, a plus b whole square and then again a plus b whole square. So we can simplify this one by opening the parenthesis by using the identity of a plus b whole square, which is nothing but a square plus 2ab plus b square. So here sine A plus cosec A whole square, this can be opened as A square, which is sine square A plus cosec square A plus 2 sine A cosec A. In the same way, this cos A plus sec A, this can be also opened as cos square A plus sec square A square plus B square plus 2AB, which is 2 cos A dot sec A. Right. Now, we know that sine theta and cosec theta are reciprocal of each other. So, in the third term and in the last term, you can see this part, this sine and cosec, and this cos and sec, both are reciprocal of each other. So, product of sine and cosec will be 1, because cosec can be written as 1 upon sine, and sine will get cancelled out. Similarly, cos can also be written as 1 upon sec, and they will get cancelled out. So, and the next step here, this thing, 2 sine square A and this cos square A. These two things, sine square A plus cos square A, that will become 1, plus cosec square A, we can write this 2 only, plus sec square A plus 2. Now, we want 7 over here. So, here right now we are getting 2 plus 2, 4 plus 1, 5. We require extra 2 to make it 7. And we want tan square and cot square, but here we are getting cosec square and sec square. Now, again, if we see the second and third identity, that was 1 plus tan square A is equal to sec square A, and 1 plus cot square A is equal to cosec square A. So, cosec square A, we can write this one as 1 plus tan square A, and 1 plus this is 1 plus cot square A, basically 1 plus cot square A, and this is 1 plus tan square A is equal to sec square A. Now, if we see the numbers, 2 plus 2, 4, plus 1, 5, 6, and this one is 7. So, 7 plus tan square A plus cot square A we are getting. So, we can say LHS, that is equal to RHS. I hope this is clear till now. Now, this one, the ninth question was there. Cosec A minus sine A into sec A minus cos A is equal to 1 upon tan A plus cot A. So, now I am giving you 2 minutes, try this question and just simplify as much as you can, and you can proceed with, let me give you a hint, in this one you can proceed in both the side, the left hand side and the right hand side both, and make sure that whenever the things are given in terms of tan, cot, cosec or sec, it's easy to convert all of them in terms of sine and cos. So, you can do it in that way also. So, like you can convert cosec into sine and sec into cos, tan into sine upon cos, and then simplify, and let's see what you are getting. Try this. I hope you are able to do this. Okay, so I'm solving this one. So cosec A, that can, if I'm solving the left hand side, so I'm converting the cosec A in terms of sine. So 1 upon sine A minus sine A, and this one 1 upon cos A minus cos A, right? Now here what we can do, if I take the LCM over here, this will become 1 minus sine square A over sine A, and this will be 1 minus cos square A over cos A, and 1 minus sine square A, we can convert this one as cos square A over sine A, and 1 minus cos square A can be written as sine square A over cos A. Now if we again simplify this one, this cos A and this cos will get cancelled out, this sine A and sine will get cancelled out, so we are left only with cos A into sine A on the left hand side. But we can see that this is not actually equal to the right hand side. So what we can do, in order to make them equal, we can work upon the right hand side also. So if you want to work upon the right hand side, what we can do, we can convert this 10 in terms of sine A upon cos A, and this cos A over sine A. Now if we take the LCM in the denominator itself, that is cos A into sine A, and cos A into cos A, that will become sine square A plus cos square A, and sine square A plus cos square A is nothing but 1. So this is basically 1 upon 1 by sine A cos A, and if we simplify this one, that is nothing but cos A into sine A. So here, so here again we are getting the right hand side also cos A into sine A, and the left hand side is already cos A into sine A. So right now we can say that both are equal, hence proved. In this way we can prove this one. And there was some question based on from that one, like these questions were there. From complementary angle example exercise, express sine of 67 plus cos of 75 degree in terms of trigonometric ratios of angle between 0 and 45. Theta should be 0 and between 0 and 45. We have to express these trigonometric ratio in terms of trigonometric ratio in which the theta varies from 0 to 45 degree. So directly we can convert, we can use the law of complementary angle here. This sine 67, if you want to convert this theta from 0 to 45, so what we have to do basically, this 67 can be written as 90 minus 23, because 90 minus 23 is 67, and cos of 75, this 75 can be written as 90 minus 15, right? Now if you remember, that was the thing, sine of 90 minus theta, that is equal to cos theta. So this will become cos of 23, and cos of 90 minus theta, that is actually sine theta. So this will become sine of 15 degree. So now we can see these are the trigonometric ratio, cos and sine, and the angle is between 0 and 45, which is 23 degree and 15 degree. So this was the thing which we have to do in this question. And there was one more type of question was there, in which it was written like, if sec of 4a is equal to cosec a minus 20, right? Sec of 4a is equal to cosec of a minus 20, where 4A is an acute angle, then find the value for A. 4A is acute angle, so we have to calculate the value for A. What will be the value for A? Now here again you can see on the left hand side and on the right hand side both the trigonometric ratios are different. So in order to equate the angle which are assigned with both of the trigonometric ratio, what we have to do? We have to convert both of them into same. So, and we know that sec and cosec are complement of each other, sine and cos are complement of each other, and tan and cot are complement of each other. So we can convert either sec into cosec or cosec into sec, because sec of 90 minus theta is cosec theta, or cosec of 90 minus theta is sec theta. So we can write this sec in terms of, we can write it like this: cosec of 90 minus 4a. This angle was 4a, so cosec of 90 minus 4a, that is equal to sec a, and that is equal to cosec of a minus 20. Now we can see that on both the sides we have the angle cosec. So we can, trigonometric ratio cosec is there, so we can equate the angles on both the side. So 90 minus 4a, that is equal to a minus 20. So 90 plus 20, that has become 110, is equal to 5a, and from here we can say a is equal to 22 degrees. This is the way in which we can proceed in this question. Only what we have to do, we just have to make the same trigonometric ratio on both the sides, and then we have to equate the angle. So CC4 center, are you getting this? How are you? Okay. And Tetso College, Shillong, I hope you have done these questions. Shillong Center, have you done these? Okay, let's move on to the next one. The one basic question was there: tan A is equal to cot B, and we have to prove, PT means prove, that A plus B is equal to 90 degree. So again, very basic one, just I am giving you 1 minute 30 seconds for this one. Do this one. Okay, you have finished. So in Shillong Center, are you Sonu typing? Oh, Sonu, how are you all? Outstanding. Okay, I hope you have done this one. It's a very easy one. You know that tan and cot are the complement of each other. So either you can convert tan into cot or cot into tan. So let me convert tan into cot. So I can write this one as cot of 90 minus a, that is equal to tan a, and this is cot b. Now cot is there on both the side, so we can equate the angle. So if we equate the angle, that will become 90 minus a, that is equal to b. So a plus b is equal to 90 degree. This is the thing which we have to prove. And any other doubt you are having? And like we have done so many things in the trigonometry, if you are having any doubt, please ask. What is the value for this expression? Cos of 1 degree into cos of 2 degree into cos of 3 degree into cos 177, cos 178, cos 179. What is the value? Yes, we have finished AP. We are today in the class at 4 o'clock. We are going to start that application of trigonometry, the height and distance. Sisipur, fast, and Tetso College. What is the value for this expression? Cos 1 degree into cos degree up to cos 179 degree. That's a very easy question. Just think properly. Sisipur Center, what do you think? What is the answer for this one? Quickly. Sonu, what is the answer? Oh, screen is not clear. Okay, now you can see the complete question. Cos of 1 degree, cos of 2 degree, cos of 3 degree into cos 177, cos 178 into cos 179. What is the value for this expression? That's right. 0 is going to be the answer because in between cos 1, 2, 3, 4, 5, you can see there will be somewhere in between there is going to be cos of 90 degree. And cos of 90 degree is 0, and 0 multiplied by anything that comes out to be 0. So answer is going to be 0. Very good. Perfect. Okay, so now we'll take a quick 5-minute break, and at sharp 4 o'clock we will start our next chapter, which is the application of trigonometry, or we can say the height and distances. Okay, welcome back students. So I hope all the students have joined. Sisipur, Tetso, Shillong. Just give me a quick response quickly. Shillong Center. Tetso College. Just mark your present. Sisipur has marked their present. And Tetso College, only you are left. Okay then, let's start with the class. So, the topic is going to be applications of trigonometry. It's a very interesting topic, by the way. Or height and distances. This is also known as height and distances. So, before starting this topic, I would like to ask you some of the question, like what my aim is in this class, what you are going to learn by the end of this class. Let's say, what you think, like, first of all, who will tell me what is the height of the Mount Everest? What is the height of Mount Everest? No, you are somewhere close, Shillong, but not exact one. Sisipur, what is the height of Mount Everest? No, neither 8200 nor 8500. You must have studied in your general knowledge, I guess in 8th class or in the 7th class. Yes, Senapati, that's right. 8,848 meter, right? Now, how you think, like, how they have measured that height? Is there any instrument to measure? Like with the measuring tape, how they have measured the height of the... Oh, that's right, that's right. So now, so this is, I was just asking this, that is not an important one. 8,848 is the height of the Mount Everest. Now my next question is, what do you think that how they have measured that height? It is a very huge mountain. So how they have measured that height? Like we don't have any, anything. First of all, let me ask you, what do you think how they have measured? Okay, Pythagoras theorem. Pythagoras theorem, okay. Angle of elevation, okay. Senapati, what do you think? How they have measured? कैसे measure करी height? Okay, good evening, Kohima Center. Okay, okay. So Kohima Center, I have just started the class, like application of trigonometry. So I have asked the first question, which is like height of the Mount Everest, which is 8,848. Now my next question is how they have measured that height. Okay, by using trigonometric ratios. That's right. So these are the tools by which we can measure the height of the anything. Right, you can measure the height of the Mount Everest, you can measure the height of Eiffel Tower. So what are the things you will require? So that are going to be learned in this class. By the end of this class, you will be able to find the height of any object or any mountain or any building if some of the things will be given to you. Some basic things will be required. If I give you those things and a calculator, you can easily calculate the height of any building, any monument. Right. So this is the aim of this class. We will learn how the heights of those large buildings or mountains or temples, how they have measured those heights. Or height of Qutub Minar as I am in Delhi. Okay. So basically, let's start with this one. Suppose this is the ground level, right? And here is some building. This is the building, and suppose there is a person who is standing at this ground level at point A. This is the point A, and here is the point B on the top of the building. Now, if the person from A is looking at exactly the top of the building, so he will look in this direction, right? So, the direction in which the person is looking from that point, from where he is standing to the top of the building, that line this is forming, this is known as line of sight. Because since the person is looking from to a thing which is at a higher level from his position, so that line is called line of sight, right? Now, you can see this is the horizontal. So, the line of sight is making some angle with the horizontal. This angle you can see, this angle which the line of sight is making with the horizontal, this angle is called angle of elevation. This is known as angle of elevation. Now, so when you are looking at something which is at your higher level, the angle formed by the line of sight with respect to the horizontal axis, that is known as the angle of elevation. Similarly, the second case would be there, in which right now the person is standing on the top of the building, the point A, and he is looking on the ground at point B. Now, since the person is looking from the top to the bottom, in this direction he is looking, and this direction is again also known as line of sight. Now, this line of sight, what angle this line of sight is making with the horizontal axis, since the person is standing on the top. So, this is also the horizontal axis. So, this angle, the person is making this angle with the horizontal axis, and this angle is known as angle of depression. Why this is known as angle of depression? Because when you are looking at something which is at your lower level from where you are standing, you have to look downwards, and when you are looking downwards, the angle formed by the line of sight with the horizontal axis, that is known as angle of depression. So there are two types of angle which we will talk about in this class. One is the angle of elevation, and second one is the angle of depression. You might be thinking that if you are taking the same case, like the same building, if I am taking A is standing over here, this is my building, and this is B. So if A is making this angle as angle of elevation, at the same point, suppose there is a person B over here, B is making angle of this one, angle of depression. So these two angles are nothing but, if you remember, these two angles are known as alternate interior angle. Since the horizontal lines are parallel, so alternate interior angle. So angle of depression is equal to angle of elevation for the same case. For the same case, like A is standing on the ground, B is standing on the top, both are looking towards each other, then A will form angle of elevation, B will form angle of depression, and both the angles will be equal to each other since they are alternate interior angles, right? So in this chapter, basically we will deal with mostly right angle triangle, as we have done in the previous chapter also, and we require only the height and distances like the perpendicular one and the base one. So majorly the trigonometric ratio which is going to be used, that will be a tangent. Sine and cosine will also be used, but tan theta will be majorly used in this one. So I hope you have remembered all the values of the trigonometric ratio. Okay, no issues, Presidency College. Now, so good evening, Presidency College. So now I'm giving you 2 minutes time. All of you make the table of all the trigonometric ratio. please make the table of all the trigonometric ratio, like sine of 0 degree, 30 degree, 40 degree, that table which we have made, and I have told you how to make the table. So in the next 2 minutes, draw all the table, and when you have finished, just update me, because those values are really useful in this one. We are going to use those values, so it is better you should learn those values. So quickly draw that table, trigonometric ratio table, fast. Let's see who draws first. I hope all you are able to draw that table. That is really essential. Okay, CC4 done. Shillong Center, Presidency, Kohima, Senapati. That's great, Shillong Center. Okay. Presidency, Kohima, fast. And one thing, tan 90 degree is infinity or not defined? Tan 90 degree, infinity or not defined? That's good. It is not defined. Don't write infinity at tan 90. Tan 90 is not defined. Okay, so I hope not defined that side, Shillong. Okay, that's perfect. Now, how in practical life, in the previous classes we have done questions in which if I give you one right angle triangle and one of the angle if I give you, you can find the other two sides of the trigonometric of the right angle triangle. Like, let's start with an example, then I will tell you in practical life how we can use the trigonometric ratio in finding the height or distances of some of the large monuments. So suppose if this is a right angle triangle, if I say that this angle is 60 degree, this side is 3, right? And so what you have to do, tell me the length of AB and length of AC. Right angle triangle is given, one of the angle I have told you that is 60 degree, and one of the base is given 3 meter. So tell me the other two sides of the right angle triangle. That's right, Sisipur. Just use any of the trigonometric ratio, whatever you think will be beneficial for you. AC, right, Sisipur. See, it's a easy one. You don't have to do anything. Just remember that if this is theta is 60 degrees, so base is given, which is 3, right? So you might be remember that thing, Pandit Badri Prasad har bole, PBPHHB. There was some other, that full form which you have told me. So this one. So we are given with the base and we have to find the hypotenuse. Then base and hypotenuse are related with the cos theta. So you can say cos of 60 degree is nothing but base upon hypotenuse. Base is 3, hypotenuse is AC. And cos 60, you should know the value for cos 60, which is 1 by 2, which is 3 over AC. So AC is nothing but cross multiply 2 into 3, which is 6. So one of the side AC is 6. Now we have to check for AB. Now again the base is given and AB is nothing but the perpendicular. So the relationship between perpendicular and base is given by tan theta. So I can say tan of 60 degree is equal to perpendicular, which is AB, upon base, which is 3. So tan 60 is nothing but root 3. So AB will be equal to 3 root 3. I hope this is clear. So these are the two sides of this right angle triangle. So this type of question will be there in which one triangle will be given to you or two triangle will be given to you. One of the angle will be given to you and one of the side will be given to you of the right angle triangle. And using that angle and one of the side, you have to figure out the other two side or one of the side, whatever the question is asking. Right? I hope this question is clear. Any doubt in this question? Any doubt? Senapati, Shillong, Presidency. Any doubt in this question? It was a straightforward question. Just the angle is given, one of the side is given. Using trigonometric ratio, we have found the other two sides. Hello, Mr. Ashish. Okay. So now this question will be presented to you in the form of a storyline. So there is a suppose this AB is nothing. So if I give you like there is a building, right? We don't know the height of the building and our aim is to find the height of the building. But we can travel the distance. Like at the bottom of the building you are standing and let's say you have moved 5 meters from the bottom of the building. So you reach to point C. So you can measure the horizontal distance on the road. You have walked 5 meters from the building and reached at point C. Now, if you know the angle, you can find the height of the building. So there is a device which is known as theodolite. This is the name of the device, theodolite, which is used to measure the angle. So what you can do, if you are having that device and if you place that device on C, and if you look from the device to the top of the building, it will form an imaginary line of sight. if you aim that device at the top of the building, like this in the diagram which you can see from point C, this is the device. So if you aim it at the top of the building, that device will tell you what the line of sight, what angle the line of sight is making with the horizontal. So that device will give you information about this angle. What angle is this one? 30 degree, 31 degree, 32 degree, any degree. So let's say right now this time it is 60 degree. So this is the information which you can get from the theodolite, which is the device used to measure the angles with respect to the horizontal. Now, this again it is forming a right angle triangle. You can see the angle is 60 degree, the base is given, and if the base is given, you can find the perpendicular, and perpendicular is nothing but the height of the building. So you can find the height of the building, right? By using just applying the trigonometric ratio. I hope you are getting. So what you have to do, you just require the distance, at what distance you are standing from the building, using the theodolite, find the angle of elevation, and using that angle of elevation and this distance 5 meter, we can find either we can find the length of line of sight or the height of the building. In all the questions in your syllabus, the angles will be like 30 degree, 45, 60. These three angles will be there. But if you see the scientific calculator, we can find the value for any trigonometric angle, like sine of 10 degree, 12 degree, 13 degree. We can also find, but with the help of calculator. Those are not counted in the standard values. So I hope you are getting how they practically find the height of the building. They just move from some distance from the building, using the theodolite, find the angle of elevation. And if the angle of elevation is known, by applying some trigonometric ratio, we can find the height of the building. Are you getting this? Is this clear, this one? Like, at the example I have given, how practically they measure? Sisipur? Okay. I am saying that this is the building you can see. This one. Suppose let's say this building is nothing but the Burj Khalifa. This is the Burj Khalifa. And we want to find the height of Burj Khalifa. We don't know. What I will do, from the base of that building, I will move some distance like this. Let's say I have moved 5 meter on the left hand side. That is I know because I have walked on the ground 5 meter. At any distance you can move. Now there is a device called theodolite. Theodolite is the device which is used to measure the angles. So if you place that device on point C, and from that device, if you look at the top of the Burj Khalifa at point B, it will form an imaginary line of sight. There will be some rays coming from the device, and if you project it at exactly at the top of the building, so it will form an imaginary line of sight. Now the device will also tell you that what is the angle formed by that line of sight with the horizontal. So theodolite will tell you the angle formed by the line of sight with the horizontal, let's say, which is 60 degree. So now it is forming a right angle triangle. You know the angle of elevation, which is 60 degree, and you know the base length also, which is 5. So in this triangle, we know two sides. One is the base and one is the angle 60 degree. So using these two information, we can find the height of the building. Now height is nothing but the perpendicular, and the base is given, angle is given. So we can use the tan angle. So tan of 60 degree is nothing but perpendicular over base. Perpendicular is nothing but the height, which is AB, and base is AC. So AB upon AC is 5, and tan 60 is root 3. So root 3 is equal to AB upon 5. So AB is equal to 5 root 3. So 5 root 3 is the height of the Burj Khalifa. Are you getting this practically how they measure? Sisipur, is this clear now? Okay. Now, this is the Burj Khalifa, right? This is the building or state building. But what about the, you can say the Mount Everest? The Mount Everest is not a straight one. It is like forming like a hill. And whenever we find the height, we require the distance from the center. Like you can see, if I draw, let's say, this is the highest peak of the Mount Everest, right? This one, this is the highest peak. Now, if I talk about the height of the Mount Everest, height means from the center of the Mount Everest, from here, from this center, this distance, this will be known as the height of the Mount Everest, and or any mountain. And these are all the stones, the rocky area. Now, if you have to find the distance from the center, from the base, how you will find the distance? You cannot go at the center of the mountain with the measuring tape. Now, what approach we will apply over here? What we will do? We will do nothing. A very simple technique, not a difficult one. Suppose at one point you are standing at point A, right? And let's now make the diagram a very simpler one so that it will be easy. This is the Mount Everest. So suppose you are standing at point A, anywhere, not as a fixed distance, and you measure the distance from point A. So when you measure the distance from point A, with the help of theodolite, what we will do? We will look at the top of the mountain. So theodolite will tell you what is this angle. Let's say this is 60 degree, right? From point A, you have measured the angle line of sight which is making from the top of the mountain. The angle is 60 degree. Now, just move some distance behind A. Let's say that distance we know from A. Let's say I have moved 5 meter, and I have reached at point B. I know the distance from A to B. I know because I have walked it through it. Now, again from B, I will measure the angle of elevation. Now, my question from all of you is that, is the angle measured from B is greater than 60 or less than 60? Quickly. The angle measured from point B is greater than 60 or less than 60? Sisipur, how it will be 60? Okay. You have written less than 60. Right. I got it. Less than 60, right? All you are getting, it will be less than 60. Let's say I am taking just the standard values. Let's say this is 30 degree, right? So what I have done, standing at some point, I have looked at the top of the mountain and I have measured the angle as to be 60 degree. I have moved some distance backward. That distance I know, which is 5 meter. And again I have measured the top of the mountain, which is 30 degree. Right? Only I have this information. With the help of this information, I have to find the height of the mountain, and height of the mountain is this part, from the center of the mountain to the top, this H. This is the thing we have to find the value. Now, if I convert this into simple geometric diagram, I can draw the diagram like this. So this is my H, this distance, this point is A, this point is B, this is 5, this is 60 degree, and this is 30 degree. So I can convert this complete scenario in this type of triangle. And using these information only, I have to find the height of the building, or height of the mountain basically. So what I can do, just let's say this point is C and this point is D. So let's say this is my X. The distance from AC is X. So you can see there are two right angle triangles over here. One is triangle DCB, that is the right angle triangle. And second you can see triangle DCA. One is the larger one, DCB, and one is the smaller one, DCA. These are the two right angle triangles. Now we are interested in finding the height. We are interested in basically finding the height and the base. So we will use the trigonometric ratio tan theta. So in the larger triangle in DCB, if I apply tan of 30 degree, so tan of 30 degree will be perpendicular upon base. So here the perpendicular is DC and base is the complete BC. So tan 30 degree is 1 by root 3 is equal to DC is nothing but H and BC, which is 5 plus X, right? This is my first equation. Now talking about the triangle DCA, here the angle is 60 degree. So I will take tan of 60 degree, that is equal to DC over AC, right? And DC is nothing but H and AC is X, and tan 60 is root 3. So root 3 is equal to H upon X. So you can take this one as the equation number 1 in H and X, and this one can be taken as equation number 2 in H and X. Is this clear till now, the complete thing which I have mentioned? Any doubt till now? Senapati, Presidency, Tetso College, any doubt till now? Or shall I proceed? Now I will not proceed, you have to proceed. If you don't have any doubt, like CC4 and Shillong Center don't have any doubt, now you can see on the board there are two equations in H and X, equation number 1 and equation number 2, and we have solved pair of equations, system of equations. So now solve these two equations by any method, but I suggest you the substitution method is helpful over here. So using the substitution method, tell me the value for H. All of you please solve. These are the two equations you can see. Using the substitution method, find the value for H and let it be in terms of root, right? Root 3, it will involve root 3, so let it be in terms of root 3 itself. Okay, CC4 given has his answer. Senapati, you are not responding today. What happened? Give response. Okay, now I am solving these equations. So just have a look whether you have done it right or wrong. So this is my first equation, this is my second equation. So from second equation I am substituting for x since I have to find h. So x is equal to h over root 3. Now I am substituting this in my first equation. So 1 over root 3 is equal to h over 5 plus h by root 3. In place of x, I have substituted this one. Now just do the cross multiplication. So when I will do the cross multiplication, or just multiply this thing over here, 1 by root 3 into 5 plus h by root 3 is equal to h. That is the thing. So this will become 5 by root 3 plus 1 upon root 3 into h upon root 3, that will be h by 3 is equal to h. Take this h by 3 on the right hand side, h minus h by 3, that is equal to 2h by 3. So 5 by root 3 is equal to 2h by 3. So from here we can say h is equal to 5 root 3 upon 2. That is the answer. See Sipur Center, you are right. 5 root 3 upon 2, that is the value for h, or you can say the height of the Mount Everest, any mountain, not Mount Everest. Mount Everest cannot be of this one. If you are now one thing you can see, like if you are leaving your answer up to here in the exam, 5 root 3 upon 2, that is also perfectly fine. But in the question, if they have mentioned that use root 3, the value of root 3 they have mentioned, then you have to put the root 3 value and then you have to simplify it further. So that depends whether they have given the value for root 3 or not. But for the sake of good, just note down these two values. Root 3 is 1.732 and root 2 is 1.414. You should remember these two values whether it is given in the question or not. Root 3 is 1.732 and root 2 is 1.414. So I hope this is clear till now. So I have discussed majorly two questions, right? Two types of questions I have discussed. First one was only the single triangle, in which one angle will be given and one of the side will be given to you. Using that condition, you have to find the other two side, right? And the second type of question which I have discussed, in which there are two right triangles, you can see. And in this type of question which I'm talking about, there are two right triangles in this one, and here we have to consider two right triangles, and then based on this one, we have to make two different equations, and using substitution method, we have to solve those two equations to figure out the unknown value. So in the entire exercise, in the entire height and distances, these two types of question will be there: single triangle or double triangle, right? Now I'm giving you some question. I hope all of you can see this. So the question number 1. So all the questions will be in the statement type, right? So this is the question. So 10 minutes time to solve the question number 1 and question number 2. Then I will solve it. Okay, Senapati, like that question you want me to ask the how I solved the equation or the entire question? Both, okay. So this was the question, Senapati. Basically the triangle was there. So this type of situation will be given to you, in which you can see this is the triangle. There are two right triangles in this one. One is the triangle DAC and second one is the triangle DBC, or both are right angle at point C. And two angles will be given, 60 degree and 30 degree, and one of the distance is given, which is 5. We have to find the value for H. So what we will do, at one time we will take one triangle, and at the second time we will take the second right angle triangle. We will frame both the equations and then we will solve the equation simultaneously. So in the first case I have taken the triangle DCB, the larger triangle you can see DCB having the angle of 30 degree. So now the complete base I know, which is first part BA is 5 and AC is X. So complete base is 5 plus X and height is H. So tan of 30 degree, tan theta is nothing but perpendicular upon base. So tan 30 is equal to perpendicular. Perpendicular is DC and base is BC. So I have just substituted the values. Tan 30 degree is 1 by root 3. In place of DC I have put H, and in place of BC the complete length X plus 5, I have substituted X plus 5. Now this is the first equation. Similarly, I have taken the second case, I have taken the triangle DCA, the smaller triangle, and in that one the angle is 60 degree. So tan of 60 degree and DC upon AC, which is H upon X. So substituting the value of tan 60, which is root 3. So root 3 is equal to H upon X. So now I am getting two equations, equation number 1 and equation number 2. Now what I have to do, from the using the just normal substitution method, you can solve both the equations. So what I have done, I have taken the equation number 2, and from equation number 2 I have found the value for X. So from equation 2 you can see X is nothing but H over root 3. Now I have substituted this H over root 3 in the first equation. So 1 by root 3 as it is, H over here upon 5 plus X. So 5 plus X, in terms of X I have written H by root 3. And then I have simplified this equation. So simplification process, you know, just find the value for H from this equation, and that value of H is 5 by root 3, which is the final value. I hope this is clear till now, Senapati. Any doubt? That's good. Now these are the questions I am giving to you. I hope all of you can see this. Oh, 1 second, let me expand this one. Okay, now these are the questions. So these are the two questions. Sisipur, the answer for first one is right. No, Shillong, the answer is not right. Check it once again. A very easy one. Just apply the correct trigonometric ratio. Now it's right, Shillong. That's right, Sisipur. The answer is right. Perfect. That's a college. That is also right. Kohima, that is also right. Perfect. Question number 2. The answer for first question is 10. And answer for second question is 8 root 3. Shillong Center, what is your answer? Sonu, are you getting it? Okay, same answer you are getting. So shall we move ahead? You want me to explain this one or is it good? Okay, explain number 2. So in number 2, it says that there is a tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degree. There was a tree like this. Okay, I will explain. There was a tree like this. Due to the storm, it got break from some point like this. So it got bent. So now the tree is looking like this. So this is, let's say this is A, this was B, and this was C. So from point B, it got bent and it bended like this. So A is here, B is here, now C is here, touching the ground. And touching the ground, so it makes an angle of 30 degree over here. Second information says the distance between the foot of the tree to the point where the top touches the ground is 8 meter. So from the foot of the tree to the point where the top touches the ground, this is 8 meter. This is the thing is given to you. Now we have to find the complete height of the building, height of the tree. So height of the tree is nothing but AB plus BC, because that is the original height of the tree when it was in the straight position. So in this triangle, what we can do, first of all, I am applying tan of 30 degree to find the perpendicular. So tan 30 is nothing but the perpendicular upon base, AB upon AC. Tan 30 is 1 by root 3, AB is 8 over AC. Oh, sorry, AB we have to find, AC is 8. So we can say length of AB is 8 by root 3. This is the first part. Now we have to find the length of the BC also. So for the BC, we can apply cos 30 degree. Cos 30 degree is nothing but base over hypotenuse. Cos 30 degree is root 3 by 2 and AC is 8 over BC. So BC is equal to 16 by root 3. So these are the length of the parts, 8 by root 3 and 16 by root 3. So just add both of them. That will be the complete height of the tree. 8 by root 3 plus 16 by root 3, that is nothing but 24 by root 3. Now, here you can say that in the denominator, in the 9th class you have studied about the rationalization. The denominator has to be irrational, and root 3 is irrational number. So what we will do, we will rationalize this one. So rationalizing means we will multiply and divide by root 3, right? So here it will become 24 root 3 over 3. So 24 root 3 over 3. So this 3, 8 times 24 will cancel. So 8 root 3 will be the answer. And I am writing over here also, in that place you can't see. 8 by root 3 plus 16 by root 3, that is 24 by root 3. And just rationalize this one, multiply by root 3 and divide by root 3. So it will become root 3 and root 3 will become 3. They will cancel out this 24 8 times. So 8 root 3 is the answer. I hope this is clear. Okay, that's right. That's great. Question number 3 is not visible directly. What I am doing, let's do the question number 4 instead. So I hope you can see it. Question number 4 says the angle of elevation of the top of a tower from the point on the ground which is 30 meter away from the foot of the tower is 30 degree. Angle of elevation to the top of the tower is 30 degree from a point which is 30 meter from the foot of the tower. Find the height of the tower. A very basic question which we have done in the starting one. CC boards. Carefully, CC board, carefully. It's not the correct answer. And in these questions, the most important thing is to draw the diagram. If you have made the diagram correctly, then it's going to be very easy question. This is not a difficult topic. Yes, Tetso College, the answer is right. CC Pur, the answer is right. Tetso and CC Pur, you can proceed to the question number 5. Yes, Senapati, the answer is right. Shillong, it is 30 upon root 3. Then it will become 10 root 3. Shillong Center. Yes, Senapati, the answer is right for question number 5. CC Pur, the answer is right. And one more thing, when you are typing the answer, please mention the question number, since so many questions are visible. So just write the question number and then the answer. Yes, Tetso College, the answer is right for question number 6. Presidency, the answer is right for question number 4. So in the one line, write like this: question 4, answer is this. Question 5, answer is this, like this. Yes, Senapati, the answer for question 6 is right. Okay, okay. Shillong Center. Yes. Presidency. The answer is right for question 5. Senapati. The question number 7 is also right. You are really fast today. Yes, Tetso College. Perfect answer for 7. Now, Senapati, you can try. Uh, for 8th one, it's not right, Tetso. Okay, so we'll take a quick break of 10 minutes over here. Then after the break, I will solve all the questions starting from question number 5 and on which question you are having doubt, right? So after 10 minutes, we'll start the question. Okay, welcome back. Let's continue. All of you have joined? Okay. So, which question you want me to explain? Just give me a hint. 5, 6, 7 or 8? Before 6, is there any doubt in 5? Okay. Question number 6. Okay. So question number 6 is, it is written a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. Angle of elevation from his eyes. From his eyes means the height is 1.5 meters. So like this. This is the boy of height of 1.5 meter, and we will assume that eyes will be on the top, and from a 30 meter tall building. And this is the building of 30 meter. So from his eyes to the top of the building, this angle is, and it is given 1.5 meter tall boy standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 to 60 as he walks towards the building. So when this boy walks towards the building, at some distance towards the building, the angle of elevation increases from 30 to 60. It means initially it was 30 degree. When he walked some distance, that angle of elevation becomes 60 degree. Find the distance he walked towards the building. So let's say this is A, this is B, this is C, this is point is D. So this time the length AD will be 30 minus the height of the building, which height of the boy. So 30 minus 1.5, which is 28.5. That will be AD. Right. So now you can see these two triangles are there, triangle ACD and triangle ABD, and we have to find the how much distance the boy has traveled. The distance boy has traveled is BC. So we have to find the length of BC. So let's say this is X, and let's say this part is Y. Now what I will do, in triangle ACD, the smaller triangle, I will apply a tangent of 60 degree. So tan 60 is perpendicular upon base. Perpendicular is 28.5 and base is y. So tan 60 is nothing but root 3. Root 3 is equal to 28.5 upon y. Second thing, I will take the triangle ABD, the larger triangle, and in this larger triangle again I will apply tangent. So tan of 30 degree, that is perpendicular. Perpendicular is going to be same, 28.5 divided by base. Base is nothing but x plus y over here. So tan 60 is 1 by root 3, tan 30 is 1 by root 3, that is equal to 28.5. And since we have to find x, so in place of y, I will put the value from the equation 1. So from the equation 1, you can see the value of y is 28.5 divided by root 3. It will be like this. Now just doing the cross multiplication to solve this equation. So we can write it like this: 1 by root 3 multiply by x plus 28.5 by root 3, that is equal to 28.5. So it will become x by root 3, and when we will multiply this one, this will become 28.5 divided by 3 is equal to 28.5. So it is 28.5 minus 28.5 by 3. So 1 minus 1 by 2 by 3. So 2 by 3 of 28.5. Right? And this root 3 will cancel out this one root 3 times. Right? So now we will get the value x is equal to 2 by root 3, 28.5. I hope this is clear till now. Now you can again simplify this one up to here, 2 by root 3, 28.5. If you want to simplify it further, you can rationalize this one, and when we are going to rationalize this one, we will multiply by root 3 in the numerator and the denominator. So the denominator will become 3 and 28.5 into root 3. So this 3 will cancel out this 28.5. So 3, 9 times 27, 9.5. So 9.5 into 2, which is 19 root 3. That is the final answer. Is this clear? Question number 6. CC4, Presidency. Okay. After this, which question you want me to explain? Okay, question number 8. So in the question number 8, it says a statue is there, 1.6 meter tall. There is a statue on some building. So it says a statue 1.6 meter tall, standing on the top of a pedestal. Pedestal means you can understand like this, a building or a platform on which the statue is there, right? So like this, there is a building or pedestal. This is my pedestal, a platform on which the statue is there, and this is some statue like this, right? It says a statue is 1.6 meter tall. The height of this statue is 1.6 meter. On the top of a pedestal, from a point on the ground, the angle of elevation of the top of the statue is 60 degree, and from the same point, the angle of elevation of the top of the pedestal is 45. So let's say the point is over here, and from point A, two angle of elevations are there, up to top of the statue and up to top of the pedestal, like this. So one angle is 60 and other angle is 45. So this angle, the larger one, this is 60 and smaller one is 45 degree. So you have to find the height of the pedestal. So height of the pedestal, so let's say this is A, so this point is B, this point is C, and this point is D. So height of the pedestal is nothing but BC. So again you can see there are two triangles, so you can take this one as Y. So all the questions will be related to two triangles. So two right triangles you can see, triangle ACB and triangle ADB, larger one and smaller one. Now if we talk about the triangle ACB, and let's say this is X. So in triangle ACB the angle is 45 degree. So I can say tan of 45 degree is equal to perpendicular upon base, y upon x. So tan 45 is 1, so 1 is equal to y upon x. Now in the larger triangle ADB, angle is 60 degree. So tangent of 60 degree, that is perpendicular. Perpendicular is the complete height, this 1.6 and y. Perpendicular upon base, which is x. So since we have to find the value for y, so what we can do, we can substitute from the equation 1. So x is equal to y. So in place of x, we can substitute y in the second equation. So tan 60 is root 3 upon y. Now cross multiply, root 3y is equal to 1.6 plus y, and when we take this y on the left hand side, it will become root 3y minus y is equal to 1.6, and y taken as common, this will be root 3 minus 1 is equal to 1.6. So y is equal to 1.6 upon root 3 minus 1. That is the answer. And now what we can do, we can rationalize this one. So in order to rationalize this one, this is 1.6 divided by root 3 minus 1. So multiply and divide by root 3 plus 1. This you already know, you have done in the 9th class. A minus b into a plus b in the denominator, that is a square minus b square, 3 minus 1, which is 2. So 1.6 divided by 2 into root 3 plus 1. 1.6 divided by 2 is 0.8 into root 3 plus 1. That is the final answer, the height of the pedestal. I hope this is clear. Any doubt till now? Sisipur, is this clear? Okay. Okay, Presidency College, that is clear. Okay, first of all, do the not the all the questions. I am looking for the some good question. Yeah. Question number 12. Question number 12 and 13. Those are the similar one. I will share it in on the WhatsApp group also. Question number 12 and 13. Do this right now. Yes, Senapati. Okay, I will share this question number 7 solution. Let's do this one first, 12 and 13. Then in continuation, we will solve all the 3 questions. Okay, Senapati Center, just focus on right now 12 and 13. Then we'll do the 7 also. That's right, Senapati. The answer for 12th. Yes, Sisipur, correct answer. Presidency, are you getting the answer? What happened? Any doubt, Presidency College? And Kohima? What about the 13th one, Senapati, CC4? Answer for 13th. That's right, Senapati. The answer is correct. CC4, your answer, please. Oh, CC4, you have found the exact answer. Let me check. No, no, no. That is not the correct answer, CC4. Presidency, is this for 12th one? Yes, Presidency, the 12th one answer is right, 19.124. Okay, I'm solving the question number 13 for you. Question number 12, that's right, Tetso College. Now I'm solving the question number 13. The question number 13, it's a very same type of question, not a different one. It says, as observed from the top of a 75-meter lighthouse from the sea level, the angle of depression of two ships are 30 degree and 45 degree. There are two ships from the top of the lighthouse. We are seeing two ships. Both are at an angle of, one is at angle of 30 degree and one is at angle of 45 degree depression. One ship is exactly behind the other on the same side of the lighthouse. Find the distance between the two ships. So see, it is like this. Let's say this is the lighthouse. On the top of this lighthouse, we can see two ships, and the height of the lighthouse is given, which is 75 meter. On the same side, this is first ship, and this is another ship. The angle of depressions are there. It means this is one angle of depression, this is second angle of depression. So I have told you in the starting that angle of depression and angle of elevation is same for the same case. So whatever is by the alternate angle theorem, this angle of depression for the ship which is at point D, that angle of the farther one has the lesser angle of depression. So this is 30 degree and this angle is 45 degree. Since that larger angle of depression is 45 and that was 30. So these are the two ships. We have to figure out the distance between two ships. It means this distance, this x, CD we have to find. And let's say this is y. So again we have two equations, two triangles we can take. Triangle BAC we can take. In triangle BAC, tangent of 45 is equal to perpendicular upon base. So 75 upon y. Tangent of 45 is 1. So y is equal to 75 in this case. Similarly, now we can take the larger triangle. So in the larger triangle BAD, tan of 30 degree, that is equal to perpendicular, which is 75 upon base. The base is the complete line, y plus x. So tan 30 degree is 1 by root 3 is equal to 75 over 75 plus x. So now you can do the cross multiplication. So when we do the cross multiplication, it is 75 plus x is equal to 75 root 3. So x is equal to 75 root 3 minus 75. Take 75 as common. So it will be root 3 minus 1. That is the distance between the two ships. And Senapati, you are asking that can we use tan, sin and cot according to our convenience, or there are certain rules to use them? No. In any right angle triangle, whatever ratio you want to use, you can, provided it should be applicable in that one. It is not mandatory that always you have to use sin or tan or cot. If you can see that that question can be solved by using sin also, you can go for sin. If you can see it is easy to go for cot, you can go for cot angle. So that's not an limitation, like it is not necessary that you have to always use tan theta. It depends on you which angle, which ratio you want to use. From all the ratio, you will get the same answer. Any doubt till now in question number 12 and question number 13? Any doubt? Okay. Now there is one good question, which is, let me show you that question. Yeah, this question. Question number 16. All of you try question number 16. It's a very good question. Use the concept of complementary angle in this one also, because you will require that concept over here. Are you getting it? How to solve this question? 16.1. Okay. Do it. It's a good one. CC4, what is the answer you are getting? That's so. CC4, Senapati, Presidency. Okay, that's right, that's right. Okay, so let me do this question. So it says the angle of elevation of the top of a tower from 2 points at a distance of 4 meter and 9 meter from the base of the tower and in the same straight line with it are complementary. Prove that the height of the tower is 6. Okay, this is, you have to prove the height of the tower. Answer is 6. So let's check. So there is a tower and 2 points are there. One is at a 4 meter and one is at a 9 meter. Now it is not mentioned that both are on the same side of the tower or on the opposite side. So you can take any case, you will get the same answer. So let's say this point A is 4 meter away. This point B is 9 meter away. And the angle of elevation from the base to the top, this are complementary. Complementary means sum of both the angles is 90 degree. So if this angle is theta, this angle is 90 minus theta, since sum of both the angles is 90 degree. This is H. So now you can see this triangle, A, B, let's say take one, this one is D and this is a C. Now in both the triangles, apply the tan theta. So in the right hand side triangle, triangle ACD, tan of 90 minus theta, that is perpendicular upon base, which is H upon 4. And in complementary angle, we have studied that tan of 90 minus theta is nothing but cot theta, which is H upon 4. Second, in triangle BCD, tan theta is perpendicular upon base, H upon 9. Now, this cot theta can be written as 1 over tan theta, which is H upon 4. So from here tan theta is 4 upon H, and there tan theta is H upon 9. This is H upon 9, this is 4 upon H. So equate both of them. So we will get H upon 9 is equal to 4 upon H. So H square is equal to 36 on cross multiplying. So we will get H is equal to 6. That is the answer. I hope this is clear to all of you. So this was all about the application of trigonometry, the height and distances part, and I will share one worksheet with you so that you can practice some more questions on the WhatsApp group. I will share. And second thing, that in the next class we will start the coordinate geometry. So just have a look on that coordinate geometry, like what are the topics we have to study, and just go through it, the chapter. So it will be easy for you to grasp the concept, right? Okay then, see you in the next class, all of you. Bye.